and put in a marker. This will be the Rust portion of the stream. So we want to do the exact same thing. We're going to want some kind of, do we have a world? We do not have a world. So we might want to end up creating a world. And the world's going to hold all of our entities. And then we're just going to be able to register entities to that. So let's go ahead and create under source here a new file called world.rs. And we'll do pub struct world. And then we know we're going to store entities. So we'll have entities. But then the type here, this is going to be a vec of, well, entities, right? So that means we're going to want like a pub trait entity. And I don't even necessarily know we need, oh yeah, we're going to have an update method on here. So we'll have a function update, which takes a mutable reference to self. And we might need to take something else too, like context or whatever. But let's ignore that for right now. And we're not going to return anything. The trio library in Python, is that good for asynchronous programming? That's interesting. Oh, and that's hilarious, Bare Knuckles, where you had a friend that had a Python library that used a little bit of async, but then it made everything have to be programmed to async, even though none of it was actually doing asynchronous stuff. It's kind of fun when that, funny when that happens, especially if you do go into promise patterns in JavaScript, and then suddenly you find well, I need to do a dot then on something that's not asynchronous. Okay, I guess I'm just converting everything to promises now. Which is a thing, I've tried to use something called the river pattern in the past, which is that's sort of what ends up happening. Okay, so now that we have this trait entity, I can say that we're going to store a dyn entity. I don't know if that box it up. I may have to. So that's going to be our entities. I don't know if we need to store anything else right now, but let's do a implements on world. So pub function new. We're not going to necessarily take anything in. We are going to return a new world. So here's our world. And we have our entities, which is a empty vector. Okay. Yes, I fixed the FPS counter. So this is actually the real FPS counter now. It is averaged over the last 200 frames, so it's not 100% accurate, but it is a lot more accurate than it was before. All right, so, and this is also the draw FPS. The update FPS is stuck to 60 frames per second, so it is a little bit interesting the way we have this working. Okay, so we have this. Now we want to register. So we're gonna have a pub function register entity that takes in a mutable self and an entity, which we happen to know is going to be, we want to give ownership to the world here. So we're just going to take ownership of it. So that means it's going to be a dyn entity, but because we don't know exactly what it's going to be, and we're not going to return anything. So instead, we're just going to say self.entities.push entity. We're just gonna throw that in there. We also know that we're gonna have update and render. So we're also gonna have a render method on this. We probably don't need like it to be mutable self, and that means we can now have an update function in this. So pub function update, and then this is gonna take mute self. We're not gonna return anything. We're now gonna loop through all of our entities. So let's see, for entity in this case, we're not gonna wanna give ownership to the loop. So let's do a reference to self.entities. This is gonna have to be a mutable reference, isn't it? Can I do that? Entities, and then we're gonna run entity.update like that. And then we're gonna have the same thing for draw. So pub function render. This is just self here. So for entity in self.entities entity.render. And so all of this works because we're aware that these types, like these functions, are on this trait, and this trait is stored in its vector, so we can call things that we're aware exist on them. We can't call anything else because we don't know what they would have, but I don't think we need to have those. And so if we need something else like is dead, so like we know for the trees we're gonna have to have some kind of like is dead on it. So, or yeah, we should probably do like is alive. So function, we could have is alive self that returns a Boolean. And so now we can have a pub function. What would this be? This would so like remove dead entities, like remove the dead. This is going to be in a vector, so we're going to store all the entities in a vec like this. Remove function, so remove dead. This is a mute self. We're not going to return anything. So I want to now loop through the entities. Essentially, I want to filter out the entities and replace the entities with that. Well, thank you for stopping by, King. I know that it is late there, so have a great night. Simple thing you can do is make use of retain and set flags in your things for destruction. That's retain. I don't actually know if I've used retain before. Is retain something on vectors? I was thinking of almost like replacing, where I could then have, let's say, let surviving entities essentially. So surviving entities. Oh, it's a collection. Okay, that makes sense. So like here's my first thoughts of doing this, and then we can maybe refactor to this collections with retain. Is just a new vec, an empty vector. It'll yell at me until I eventually figure out what to put into it. We would actually, I could straight off from the bat just do self dot entities. I could take ownership of this. So let's just turn it into an iterator, and then I can filter it. And then I have an entity. and I want to return the true or false. So it's going to be the entity dot is alive, like that. So if the entity is alive, then we want to filter that, and then do I have to? I think I have to collect it back again. So if I do that, now surviving entities is back. Oh, it's not telling me what the types of this is now into here, and then I can replace by saying self.entities equals surviving entities. Not very efficient. We're creating an entire copy of like how many entities we have, which will use a heck of a lot more memory. So it's doubling our memory essentially. So this is like first naive approach that I have for this. You did this for a small multi-user server to drop dead clients. Clients.retain c.state. Interesting. Okay, so let's try. I want to record that down. So first of all, this is from Bare Knuckle Waffle. Your suggestion is essentially a self.entities.retain. Do I have to turn into an iterator first? And then I can put into like our entity. Oh, you don't have to. Okay, so you don't have to turn into an a vector. Okay, that's nice. And then is it whatever is true is retained? So is alive. So entity dot is alive. Basically that. It's whatever you make the closure test. Well, I figured that. I guess truthy here, like whatever is true, if it returns true, it keeps it. And if it's false, so it's like a filter essentially. In my case, basically keep anything that's not disconnected. Nice. All right. I will try this after that. You keep anything that's not off screen. Yeah, exactly. Okay. Thank you, Barry Knuckle. This looks really awesome to use, and we'll like simplify this by a huge amount and potentially use a lot less memory. So that's all good. Now we need to actually use this world, because this is gonna run the update. It's gonna run the render. We're gonna add entities to it and remove entities from it. I think there is an inverse that will drop things in the same vein. That I have noticed that there are, like, Rust does tend to have those. Those are pretty nice. Let's go ahead and now register the world. We'll store the world, and then we'll start registering entities and updating them. So let's start with the player first, because there's only one of them. And we'll just see how far we can get before the end of our time. So in our main library, we need to now mod. So mod our world. I did call it world. Yes, I did. Also, you came up with an error right away. What's our error? Okay, so you need to be boxed up. So we do need to dyn box, and then in here, oh no, it's going to be a box with dyn entity, like that. Which means you need, like, all this needs to be the same thing. So we need a box of dyn entity, and then we can push the entity straight into here. All right, so what are you upset about? Self.entities. Cannot move out of self.entities, which is behind immutable reference. Right, okay. So I would need this to be mutable entities to sort of like do that. Maybe we should try the other one first. Let's try you first. And see what you say, compiler. You seem to be fine with this. So the box-type entity, return that. Retains only elements specified the predicate. In other words, remove all elements E such that E returns false. Okay, so if I return true, we keep it. False, we lose it. All right, I think that's good. I think this is exactly what we need. So we don't need this at all. And now we're going to, we have no errors. Let us use world. We also need to use off of here entity. And we're going to store the world is a type world. So in a new game, we are going to need to create the world in here. So let world, we're going to want this to be mutable because we're going to be immediately adding in the player into this. So world equals world new. And let's go ahead and store that in here to make it happy. So here's the world. And maybe before we add anything in here, let's go ahead and add the methods to update the world. And we're going to update the world, and we're going to render the world, and then delete the dead stuff from the world. So those are the three things that we're going to do with this. So in update, while we're playing, so let's go ahead and we're going to do self.world.update and self.world.remove the dead. How retain works, essentially what you were trying to do. Is that not what I'm doing here? Take a look at that. We have disable feature plug function retain where, oh, this is like behind the scenes, like what retain is doing. So figure out the length, delete. Yes, this is like having to use the predicate, call it. If that's truth, the delete. Okay, yeah. Manipulating arrays like that, not the funnest. Yeah, that it's sort of like a filter, like in my mind. It's very simple, except it doesn't return anything. It internally mutates, which, I mean, it's sometimes nice to be able to do that. Okay, so we have update, remove dead, and then in draw here, which one do we want? We have our game state. Okay, so if we're playing, then we want all of our entities to draw. So game state playing, we have graphics draw here, graphics draw. We have the draw score. Let's go ahead and like at the beginning, do self.world.render, and that'll be that. And it doesn't blow up your order, which is super helpful. Yeah, I can see that. So this is running, or this is no errors, so everything should work. Of course, we're not using world yet. We've just sort of integrated it in. Let's go ahead and add the player in first. So adding the player in, we need to, so here's our player. We need to give ownership of the player to the world. So we need to register the player with the world, which we can do right after here. No, I don't want to, like, player create mesh. I don't want to consume the player until I'm done with it. It's like player add observer. All right, so then maybe at the bottom here. We can do this all down here. We're gonna do world dot register entity, and we'll add the player in. Now, of course, it can't just be the player. We have to box the player up. So we're gonna do box new player. Now, problem: the player doesn't implement. Entity is not implemented for player. So now we have to go into player and implement entity. If you're boxing player, shouldn't we call it a casket? I'd have to change the shape. Source. Oh, right, it's a mod. Mod in the player. So let's see. We want to use super entity. Oh, don't do it. Okay, hold on. I just full screen this. You go away. And so we implement the player, implement subject for player, and now we're going to implement entity for player. And so now it's going to yell at us because we haven't implemented all these three functions. So we need update, render, and is alive. So function update. I always sad that it doesn't do like the self properly. I thought Rust Analyzer was doing that for me. Function update. That one does it. Okay. Okay, so here we have our update function. If I just stub these out to begin with, so function render. And function is alive. Okay, this is the only one where you have to like return a Boolean. Players are always alive for right now. So let's make this just true. We're returning true. If I do this, we register the player. We have two errors. Let's go take a look at what it is. Use a moved value. Right, so now we're no longer going to want to store the player here. So this is going to be interesting. So the player is no longer stored in our struct. Let's remove you from there. Remove you from here. Use a move value player. Oh, hold on, I have to save it. No field type player on my game. Okay, so then here we're gonna have like player reset. So now we need to figure out how do we reset the player. This is probably gonna be a reset system that is gonna have to run across the world. So if we make all the entities public, on world, then I could have a reset system or just like a function that takes in a reference to the world. It'd have to be a mutable reference to the world, loops through that, gets all the players, and then runs reset on it. Gets all the entities and runs reset on it. Okay, so that's going to be the next thing we're going to have to do here. So I don't know necessarily where like where to put that. I could put it into world for right now. Because I could do like, I could put the systems like attached to world, or I could do like just a variety of systems, like an entity system. What if I create a new folder and I call this like the components? No, entities. I could just call this world. We're going to throw world.rs in here, move that, rename you to mod. In the library here, what needs to change? We mod the world entity. Actually, that still stays pretty much the same. No field player on type new game. So now we have the same issue, but in the world now I can start creating the systems for this. So I want reset game. I guess we'll call this the reset game system.rs. And this could essentially just be a function, can't it? So pub function reset game system. I don't know if this needs to be a struct fully. What does it need to take in? We know it needs to take in the world, which is going to be a mutable reference. So let's use super that goes to world here. So that's going to be world. If we do a mutable reference to the world and we don't return anything, we now want to loop through all the entities and call reset on it. So this is going to be, then world is going to need to have its entities public. So for entity in mute world dot entities. Then let's go ahead and call entity dot reset. The only way that's going to work is if that okay, so we're going to do entity dot reset. Okay. But you're going to be upset because there's not going to be a reset off of entity that it's aware of. So now in world here, off of entity, we're also going to have the function reset. Mute self, like that. So now instead of this reset game, where the player is reset like this, function reset game, we're going to need to get that reset game function and pass in the world. So let's go ahead and use I guess it would make sense to we're going to do world. World is going to have to mod this. Mod reset game system. Okay, you're not unhappy. That's a good sign. Okay, so world. Wait, how do I get it to find? Oh, I need to pub mod it. So I re-export it. So here's reset game system. And we need to pass in a mutable reference to the world. So mutable reference to self.world like that. And that should handle that there. Then player.reset can go away. Now, what are you upset about? Expected function found module world reset game system. Oh, do I need to do this reset game system like that? It's a little bit weird. What did you miss? Dogs told me not very much. I'm trying to create like this system for resetting the game that runs like a reset method on all of the entities. Expected function found nothing. So world reset game system, reset game system. Oh wait, how? What? Don't do that. Autocomplete. Okay. This is happy specifically. No field player on type. Okay, so then run. This will have to be the update. And so we're taking in the command, the arena height. So a reference to whatever commands are created, the arena height, and gravity. So does everyone need to know what these are? And I guess potentially this is where the different systems come into play. When the player is running, what does that really mean? What does run do? It's like checking the state. It's applying the force to like make it go down if it's like depending upon what state it's in. Sounds to me like this would be a system then. Just by naming it, it would see an arena height and gravity would belong in the world. Yeah, gravity would belong in the world, not on the player. Yeah, it's being passed in right now. So that could still be passed in when the world is doing that. Let's take a look at the first part of this. So we're passing in the command. The command is sort of like what command is being returned. Okay, so that kind of makes sense. We need to pass in the command to the player, but in reality, I want a system to where I can like run the commands on things that like take commands. We happen to know that there's only one thing that can take a command that would be an entity, which would be the player. The obstacles and the trees can't take commands. Like they don't work that way. What is self in which context? This one? It's for the player. Oh, self.player? That's off of the main library. So because I'm now having the world on this won't be viable. So I just have to figure out how to make it so I can run essentially this function off of player, or maybe like the update function. Now I could also just say, hey, everyone takes a command. But that doesn't make sense because only certain entities take commands. None of the other entities care about it. So I want to do that thing where we filter through, query for the entities that can take commands, and then grab those separately. And so that sounds like a type, like sort of a type system. Now my entire like doing entities off of this is not going to be the most. It's not going to be very efficient. Like compared to like specs or like a real ECS system, mine is not going to be like memory efficient or frame efficient. It'll probably slow the game down. Um, but I'm not worried about that. If I want it to be super fast, I would just use them. Let's see. So if I want a command of this type, efficiency later, make it work how, well, like if I rebuilt this, I would just use specs and then I wouldn't have to do any of this type of stuff. But this is like teaching me how like to use specs properly, if that makes sense. Because I'm gonna like learn how these type of things work. So I'm gonna want, so we have this reset game system, which is a function that takes in a world, it goes through all of the entities and calls resets on them. What I'm wondering if I need another reset for I need another system for like command. Or like update, and then I can run that function here, which would like hand it a reference to the world, and it would go through and do the thing. Is specs and ECS the one in Amethyst? So specs is the ECS system that was in Amethyst. Amethyst, I believe, has switched over to, oh, I just forgot the name of it. It's a different ECS system. Legion, yes, that's right. Legion, they switched over to Legion. But I've tried specs in GGEZ, and I actually liked it quite a bit. So we want to be able to hand it the command. The arena height and self.gravity seems pretty simple to hand into the update. And so maybe this is also something that we have to like completely switch how we store the data. We don't want to store the players as like individual objects anymore. We want to just create an entity struct. So maybe we don't want entity to be a trait like this. That would be interesting. So just out of curiosity, if I create like an entity.rs here, let us go back to play. Okay, so let's undo some of what we did. In fact, you know what I'm gonna do? Because we haven't stored any of this. Let's go to get Kraken. Let's create a branch here called maybe going to like traits. We'll just store all these changes. Whip maybe traits for entities. But what I really want to do is come back to master and take a look at what would happen. Let's close all these windows again. Nope, not all the windows. If I created an entity struct, so off of a source, if we created like an entity.rs, and then our main library, we're gonna mod that. Okay, so that will make it so now our entity will start being used. So let's do a public struct entity. And so then in here we start sort of like figuring out and adding in what an entity would have. So I can maybe like register, okay, an entity has like a name, a type, and then we're going to want to store. Okay, and that's where we have like our other. So what is it that specs and entity component system has? We have systems, and we have components. So then we can have like the components that the entity has that are stored inside of here. So if we want a player, what does like having a player mean? It has like a location, right? Does that mean we just have I wouldn't necessarily store location. Well, do all of our entities have locations? We have player, obstacle, and trees. I mean, they kind of do. So I could do like a location. Like every entity has a location. All right, so use GGEZ, NA algebra, vector 2. And so I can say, okay, this is always going to be a vector 2 of F32. So I can say that, okay. Our entities all have locations. However, that being said, if I do it in the specs way, player should know things like its velocity, mass, vector, and transform. Right, but the player doesn't have a velocity, which is interesting in this case. Everything else has a velocity as it's sort of like moving towards the player. Although that would have been nicer to like the player has the velocity and everything moves like compared to that. That probably would be a better way to organize it. But okay, if I have like our entity, it could have a location like that. But what if I also did like a pub struct, and then we have the components, right? Oh, I guess it'd be a trait component. So if we had did a pub struct location, and this would essentially be a vector 2. I guess in this case it would be like a tuple. So a vector 2, F32 like this. But then I want a trait for a component. So pub trait component, which I don't necessarily have any functions to go in it yet, but now I can implement impl component for location. To be fair, in this instance, you treat everything as similar generic things, so a player and an enemy would basically have the same stuff inside, whether it uses it or not. And to be fair, your player should have a velocity. It's just the vector is always vertical because it jumps. Oh yeah, that's true. It does have a velocity, but I think it had. Do I have a velocity for it? I think I do. Oh, I have a player data for this. I think this will get rid of the player data. This would, I think, like switching over to this system would switch this over. So I think this is going to be a bigger undertaking. Don't think of jumping as something different than walking left or right. Yeah, that's probably definitely true. So let's say we have this location. But if I wanted to do this, where I have like necessarily like not necessarily like entities is not location here, but we do this location here. Now we're going to have components. Which is going to be a vector. And this is going to have to be a box of Dyn components. So if I end up doing this, our entity is the player, and the player has a location. So I think that's like what the ECS system is like. We say, okay, we have a player entity, so new entity, and the entity has a component. I could have like a type on here, or like a name in case like it will help. So I could say pubstruct entity, the name would be static stir, something like this. I probably want to use like a builder pattern for the entity, just like we do with the ECS system. So I can just say, okay, entity, give me a new entity that has a name. I mean, I guess I could just do a straight up vector of like all the components we want to add in. That's fine too. And then we can have the system, which is just a straight function that says, okay, I want to now handle the input, like jump, for all of the, all of the things that can jump. So that might be what we want to do. I'm going to have to do that next time, though, because I'm getting dangerously close to my stand-up time. But even just walking left and right, you should technically be applying that same gravity anyways to stay rooted. So the way I'm mentioning specs, or I guess ECS in general, your player NPC would be the entity. Yes, I would have the trees are entities, the obstacles are entities, and the player is an entity. But they all have different components. And so I say, hey, all components that have a velocity, update their location with the velocity. So all components that have a location and a velocity, update those. All components that have a draw those. All components that have a, I don't know, like something else, do that. So that's kind of what we're going for here. So I'm going to save this as a work in progress, as it were. But I think this is going to be closer to what we really need. It's going to be a huge refactor of our game, but I think this is going to be the best state that it will be in. So I don't know if I'm going to keep like entity in that file, or if I'm going to move it into like a folder system. Sounds like a convoluted SOA. I guess so. What's an SOA? Or am I just not familiar with the? I may know what it is. Struct of arrays. Yeah, and a ECS system is generally considered a struct of arrays. Okay, so we have master here. We'll store all of these. And our summary is work in progress, moving towards an ECS system. Yeah, ECS is generally used in arrays, or vectors in this case. It sort of like, it's very interesting the way it works. I guess like specs is nice because it doesn't have to be arrays. It could also be hash maps or anything else to that end. But with that, I don't have much time because I have to rush off to my stand-up, which is in less than 5 minutes or so. So thank you everybody for stopping by and watching this. I am super looking forward to implementing essentially an ECS system. I know we've been moving towards it, and now we're finally there. So with that, let's switch to the ending screen. Arrays being purely any collection, not purely arrays. Yeah, agreed. Anyways, have a great weekend, everyone. I will see you next time. Next official stream will be Monday morning at 7 a.m. Mountain Time. I don't know if I'll stream this weekend, but you can follow me here on Twitch or on Twitter for notifications just in case I do. And with that, have a great day, and I will see you next time.